Okay, welcome to the first episode of my YouTube series on evolution. Going through it, we're going to bring you from any level of understanding to a university level understanding on the topic. If you want a sort of preface to the course, there'll be a link in the description. But if not, let's get right into it. So, evolution relies heavily on one thing: natural selection. And also a surprise second thing we'll talk about in a moment. But first, natural selection. Now, natural selection requires two things: heritability and variation. So, variation, let's start with that, just means that organisms differ from one another. And these differences result in them interacting with the environment differently. So, like a snake will be able to come across an area and access it, and a human would not be able to access that area. And a human might be able to reach a branch a snake would not be able to reach. And, this is pretty clear. Animals look different from each other, so they interact with the environment differently. And heritability just means that an organism inherits the traits of its parents. So two long snakes are more likely to produce a long snake than two short snakes. And just as a byproduct of these two factors, natural selection occurs. So since there are variations, certain organisms are going to do better in their environment. And because of that, they're going to consume more food and have more children in their environment, and therefore, over time, due to heritability, they're going to pass their traits on to more and more children and become more prevalent in that environment. Now, if that's unclear, let's take a look at an example. In this cold environment lives a population of bears. Some of these bears are hairy, some of these bears are partially hairy, partially hairless, and some of the bears are completely hairless. So because the environment is cold, it's an Arctic environment, bears with no hair have to spend half the day in the den warming up. Bears with partial hair covering only have to spend a quarter of the day in their den warming up, and bears with full hair don't have to spend any time of the day in their den warming up, so they can spend all day hunting. As a byproduct of this, the hairy bears are able to get more food and feed more kids, and therefore have more kids. The semi-hairy bears, not so much, and the hairless bears, really not so much. So over time, the hairless bears become a smaller and smaller and smaller portion of the population, dying out. Then, even though the semi-hairless bears do better, you can see they become still a smaller and smaller and smaller portion of the population until they too die out. And then, the hairy bear becomes the only bear in this environment. Now, with that, you can see how natural selection sort of acts as a filter. It picks, just through the way that organisms work, the best fit organism for the environment. Just naturally, organisms lesser fit for the environment die out. But, as we all know, evolution makes radical changes over long periods of time. We've seen historical animals like the dinosaurs that look completely different to creatures we have today. And that doesn't seem to be explained by natural selection. But this can be explained by a secret third ingredient, the one we talked about earlier, mutation. So, and we'll get into the chemical explanation of this in later episodes, but organisms sometimes spontaneously gain a new trait that they did not have before.
Quick note here, and I'm making this edit because I didn't make this clear in the initial recording. But the kind of mutation we're talking about here happens during the reproductive process, in that animals don't just get new traits in their day-to-day life. This happens when the organism is being conceived, specifically when the genetic code is being copied. So a new baby organism is born with a mutation. It doesn't just kind of pop up in their day-to-day life. I just want to make sure that was clear.
Now, these mutations are almost always small, but the small changes can accumulate over time. So, essentially, mutations that give the organism a small amount of benefit in the environment can become dominant. Then mutations can happen on top of that. And over a time scale of millions of years, the changes can become so radical that you don't even recognize the creature as the same species. And so, these mutations can cause drastic changes. Now, let's take a look at speciation. What is it? Well, basically, one organism, one species, can split into two over time. And let's see how this is done. So, back to the bear example from earlier for this one. We have the population that has newly become dominated by only hairy bears. There are no semi-hairless bears left, there are no hairless bears left, because the hairy bears were the most adapted for the environment. But now let's imagine a mutation pops up. In just one or a few of these bears, a gene was changed, and again, we'll figure out how this works on a chemical level in another episode. But a gene was changed that resulted in the bear's fur being completely white. Now, in their northern Arctic environment, the white fur allows them to much easier sneak up on prey. So, they start becoming more and more prevalent in the population. However, down south, a little bit, where it's still cold, and so the hairy bears have become dominant in that population too, it's less snowy and less white and less icy, so the completely white bears actually stand out more. So they're able to hunt prey less effectively because they're not as camouflaged. So in that population, the hairy bears actually do better. Over time, we're going to see the white bears become dominant in the northern area, and the brown bears become dominant in the southern area. And this is the sort of thing that happens over time. And if this continues to happen, you're going to have a lot of different varieties of bear, and maybe things more than fur color are going to change. So over the course of millions of years, one group can split into many, many different groups in different environments. And so in its most condensed form, evolution can be explained like this. Natural selection is a filter. Organisms go through, and based on how well they do in their environment, some of them die off or are bred out. And mutation constantly provides new material for natural selection to filter. Okay, that's the end of the first episode here. I hope you enjoyed and learned a little from it. And we're going to continue going. The next episode is going to be out soon. And I think we're going to cover Punnett squares and probably dabble in chromosome inheritance and possibly even types of speciation. So I'll see you in the next one.